Okay, so let me start by reminding you what we talked about yesterday when we were drawing our line segments and I sent you home with your compasses and I said, go construct the midpoints of these line segments. And I said this was the synthetic part of the lesson. So today we're going to do the analytic part of the lesson. So we're going to be using our algebra skills to figure out the lengths of line segments, the distances between 2 points, and the midpoints that you guys hopefully came up with doing your constructions, and we're going to verify those again using our algebra. So the whole idea today is we're going to be looking really at the same math problems we did yesterday. We're just going to look at them from a different perspective. Yesterday we looked at them synthetically by drawing them and graphing them and constructing segment bisectors. Today we're going to look at them analytically with algebra. Okay, and so the idea is for you to be able to get two different looks at the same math problem to get a better understanding of how all these things that we do come together. That's the idea. All right, so let's start with the notes that I just put out there in front of you. So you should have this paper right here out in front of you, and you may or may not be familiar with this already. But I want you to see how it plays into what we've been doing in geometry, okay? And so we're going to talk about today the distance formula and the midpoint formula. Now, formulas are just mathematicians' way of saying, hey, here's how to easily figure out a value or an answer by plugging in a bunch of numbers, okay? That's what formulas are in terms of mathematics. And so the distance formula, you can see right here, it says, finds the distance between 2 points, this one, and this one. Now, I just want to be clear about something real quick. You can see, let me just kind of zoom in here for a second. You're going to write this down. But you can see here that these 2 points have these little sub-notations on them, the sub-notations of 1 and 2. Okay, those are not mathematical notations. That's not telling you to do any kind of math. They're not exponents. They're not saying multiply these numbers by themselves a certain number of times. They're just naming notations, okay? And so really, what these naming notations are doing is indicating that this right here is just ordered pair number 1. And this right here is just ordered pair number 2. Or if you want to think about it synthetically, endpoint number 1 and endpoint number 2. That's what we're talking about. Right? We want to find the distance between 2 endpoints on a line segment, so we need to have the 2 endpoints. Okay, so we're going to call them ordered pair number 1 and ordered pair number 2. And so when we use these little sub-notations, all I'm saying here is this is the x value from ordered pair number 1. And this is the y value from ordered pair number 1. And the x value from ordered pair number 2 and the y value from ordered pair number 2. It's just a naming notation. Okay? And again, because we can name segments AB or BA, it doesn't really matter which endpoint we call 1 or 2, as long as we're consistent with how we use it in the formulas. Okay? So let's write down the distance formula. So the distance formula looks like this. Distance is equal to, and then you're going to do a nice big square root sign way out there like that. Okay, so a nice big square root sign way out here like that. Everybody's taking notes on their paper right now. Okay, now, I'm going to show you as I write it down here how you're going to type this into formative to make it really easy on yourself, okay? So when you're typing this into formative, you're going to do it like this. You're going to enter your segment length like AB equals in a big square root sign. You'll get a little placeholder in your formative. And then how I'm going to recommend you do this is you're going to do an open set of parentheses plus an open set of parentheses inside your square root sign. And then you kind of like arrow back over on your formative and you make sure that your parentheses are squared. You got to put a little up to the top too. Okay, now inside your parentheses, you're going to have some subtraction problems like this. And then when we write the distance formula generically, the way we write it is x2 minus x1, or x sub 2 minus x sub 1, the x coordinates from the second order pair and the first order pair, plus y2 minus y1, like that. Now, could we switch the x's and y's? Well, sure, it's an addition problem. 2 plus 3 is 5, 3 plus 2 is 5. It doesn't matter what order we do it in. But because you're trying to get some points on formative, you're going to match it. I'm going to say in the first set of parentheses, you're going to put your x values. And the second set of parentheses, you're going to put your y values. Again, I have it set up so it doesn't matter which one you call ordered pair 1 and ordered pair number 2, okay? And also when you write your distances like A, B, or R, S, write them in the same way that I listed them in the problem, and then you'll be getting your full credit on your points, okay? So this is our distance formula. I'm just going to kind of put a little color around this so it just stands out to me. And this is how we calculate the length of a line segment, okay? Analytically. This is how we do it analytically. Now, we also have a midpoint formula, and this allows us to calculate algebraically that place where the segment bisector crosses. So the midpoint formula looks like this. We're just going to say mid. That'll be the name of our midpoint. In most cases, it'll just be a letter. And the midpoint formula is actually just a big ordered pair. So this is how you would type it in to formative. You're going to do an open set of parentheses, and then you're going to create 2 fractions like that. You're going to create 2 fractions. So you can see I'm making an ordered pair. On the left is the x value, on the right is the y value of my midpoint. Okay? Now, the way that the midpoint works is I'm going to take the 2 x values, x1 and x2, and I'm going to add them together. And then I'm going to divide that value by 2. So that's how I find the x value for my midpoint. And then to find the y value for my midpoint, I'm going to take the 2 y values from my ordered pairs or my endpoints. I'm going to divide them by 2. When I do those math problems right there, I'm going to end up with the x-coordinate and the y-coordinate of the midpoint. And that's how we'll calculate our midpoint analytically, algebraically. Okay? We'll put a little color around that so it stands out. So we have this to work with. All right? Okay, so let's get started with calculating these analytically. You should be looking at something that looks like this now on your screen. Yes? Everybody good? Okay. All right, now, hang with me on this first one so that you learn how to do this, typing things in and putting your work down correctly, and then you'll be able to do the rest of these fairly easily, okay? All right, so let's start by going to the show your work section here, okay? Now, we'll deal with the typing into formative in just a second, but I want you to notice that on the left side of this box here, it says, upload your graph here. Okay, so here's what you're going to do. You are either going to scan and or take a picture of your graph for problem number 1, because you can see we're on problem number 1, just problem number 1, and you're going to crop that so it's just the graph from problem number 1, and you're going to upload that into this space right here. Now, this is how you do it, okay? Once you get it on your camera, on your photo, on your iPad, you're going to click this little mountain button to open up your upload window. And then you just click in here. It'll give you a little file thing. And then you click on the picture that you took. And that will put it up in here. Now, don't use the formative take a photo option, okay? Because you won't be able to crop it in formative. You're going to have to crop it in your actual photo app. All right? Now, I'm going to come around and help you guys get this done. And then we'll take a look and see where we're at. So that's our first step for right now. Okay, here's a good example of what it should look like. Take a look up here. This is a good example of what it should look like. So you've got number 1 cropped out. You've got your graph up there. You fit it on the left side, okay? So it's a good example of what it should look like. Lauren, you got to make yours bigger. I like this one too. This is one of the scanned ones. You can see that with the scanned ones, the colors are really bright. The graph looks really good. So this is what one of the scanned ones look like. This is a good one. Let's get started with our analytic portion of what we're going to be doing here, okay? All right, now, we're going to do this one in pieces, and I'm going to show you how to type it into formative so it's helpful for you, but I'm also going to show you how to properly write it. So make sure that you're paying attention. So if you've kind of moved on to a different thing now, come back, all right? And let's focus on what we're doing here at the front because I need your attention so you don't miss something important, okay? All right, so let's start talking about how to find our distance. So we're going to start with the distance of this line segment AB. Now, the good news is we already know the distance. We're going to do this one just so that we can see how the algebra verifies what it is. Right? Look at your paper right now. How long is the distance of AB? How long is segment AB? AB. 8, right? Because from A to B, we can count 1, 2, 3, 4, 5, 6, 7, 8. So we should come up with 8 when we do this algebraically. And let's see what happens, okay? So here's what we're going to do. We're going to start with our distance of AB. So I'm going to write AB equals, right? That's the length of the line segment AB equals, and then I'm going to do a nice big square root sign. And then I'm going to start with some parentheses squared inside my square root sign. And then I'm going to have some subtraction problems inside my parentheses. And that's a good blank template to start all your problems with right there. Now, from there, I'm going to go and start putting my numbers in. And I'm even going to use a different color to write my numbers in here so you can see that it's really clear. Okay, so we have point A. If you look at your synthetic side, point A is at -2, -4. Point B is at 6, -4. I'm just going to pick point A is going to be ordered pair number 1. Point B is going to be ordered pair number 2. Again, doesn't matter. You could choose which one. I have it set up to work both ways, okay? But we're going to call A ordered pair number 1 and B ordered pair number 2. So if that's the case, then what I want to do is I want to subtract the x values ordered pair number 2 from, or ordered pair number 2 minus ordered pair number 1. So that means I need to go 6 minus, now the x value for ordered pair number 1 is -2. Does everybody see that okay? I got to put that in parentheses because I don't want 2 operators in a row, so I got to go 6 minus -2 like that. See the double parentheses in there? One parenthesis is for the whole squared group. The other one is just for the -2. Now I want to subtract my y values. So my ordered pair number 2 y value is -4. Well, and actually it's -4 for my other one too, huh? So I'm going to put that in parentheses like this. Okay, you see that right there? When we come back to it, that's what you're going to type in for step 1 into formative. In fact, let's just do it right now. We'll type it in right now just so you can see how it goes. So I'm going to do it for you up here on the screen. Watch me first, okay? I'll make your life really easy here. All right, watch me first. So I'm going to click into my little math keyboard here, and I'm going to show you how to do this. All right, so watch. The first thing that I'm going to do when I start typing my answer in for number 1 is I'm going to go AB equals capital A, capital B equals, no line over the top because this is the distance between points A and B. Okay? You can do this with me if you want. That's fine. We'll do this together. So type in AB equals. All right, now here, watch. We're going to start with a square root sign. Now, inside that square root sign, you can see I'm highlighted. Inside that square root sign, I'm going to go parenthesis group, and then I'm going to just click or arrow right next to it. And then I'm going to go plus, and you'll see my square root sign continue out. And I'm going to go parenthesis group. See how my square root sign automatically carries over? Now I can move around inside my square root sign. See me moving around inside there? Right? And so I can come to my first group, and then I'm going to do my shift 6 to get my little exponent, or you can click the exponent button on the keyboard. And I'm going to put a squared on that first set of parentheses. And then I'm going to come over, and just outside that next set of parentheses, I'm going to put a squared as well. There's your blank template right there to start with. Now I can edit my insides of my subtraction problems. So my first subtraction problem was 6 minus -2, right? So I'm just going to go 6 minus, and then I need to put that -2 in parentheses. So I'm going to grab this little already pre-made parenthesis group, click it, and -2, just like that. See how I did that? 6 minus -2. And then over here, my second set of parentheses, I'm going to go -4. Whoops. -4 minus, and again, I need to put that in parentheses. So I'm going to grab my little pre-made parenthesis group here, click it, and -4 in parentheses. And that's how I get my, there it is right there. It's probably easier here. I'll click on this. It's easier to see on the math keyboard, okay? So make sure your square root sign goes all the way out. Now, if you type it incorrectly, if you type it into formative correctly, you should get 1 point for this question. All right, so it should turn green, or it should tell you got 1 point for this correction. I'm going to come and take a look and make sure that you are tracking on pace. So next up, you'll see that the next line that we have to type in says simplify the subtraction problems, okay? So it says simplify the subtraction problems. So here's what we're going to do for our next step. All right, so our next step is going to look like this. We're going to say AB is equal to, again, I'm still going to need a pretty long square root sign. And now I'm going to do the math inside my parentheses for my subtraction group. So for the first one, I've got 6 minus negative 2. So what's minus a negative? What happens there? Right, it becomes a plus, right? It's opposite of a negative. So what's 6 minus negative 2? 8, positive 8. I'm still going to put that in parentheses like this. So when I type this into formative, you're still going to start off with the parenthesis group plus parenthesis group squared. All right, now let's do the next one. So it's a plus. All right, so I've got negative 4 minus negative 4. Okay, minus negative 4 becomes plus 4, right? So it's minus 4 plus 4. Okay, 0, good. So we're going to put in a 0 here, like that, right? All right, so this right here now is what you're going to type in on the next level where it says simplify subtraction problem. So I'll do that with you. I'll do that one with you too. So let me click in there. All right, so again, I want to make sure that I type in my length for my line segment. So I'm going to say AB, whoops, I want capitals, right? AB equals, whoops, B equals, and I'm going to start with a square root bar. And underneath that square root bar, I'm going to do a set of parentheses plus a set of parentheses. And then I'm going to get right outside my parentheses. I'm going to make sure that those each are squared. Just like that. Just like that. That's how you're going to start off. And then this one's going to be pretty easy, right? Then I'm just going to go in and I'm going to put an 8 there. And I'm going to put a 0 there. And I've got my second level of my problem. Okay, how we doing? Everybody good so far? Okay, let me just check and see where you're at. Now we're ready to kind of tackle the next section here. So you'll see that the next line that we're going to type in says exact answer as an equation, right? So that means we're going to simplify the inside of our radical and then we're going to take the square root. Let me say it one more time so that everybody who isn't listening is listening. You first simplify the inside and then you take the square root, okay? Always simplify the inside first, then take the square root. So in this case, it's going to be AB is equal to the square root of 64 plus 0. Get in the habit of writing each of those out because in times there will be different ones. Then we're going to say AB is equal to the square root of 64. And 64 is a perfect square, right? Remember that square root sign asks the question, hey, what times itself gives me 64? Well, how would you answer that question? What times itself gives me 64? 8, not the square root of 8. Don't write that. Write 8. Just the number 8, right? AB equals 8. Well, that makes sense. Isn't that what we just said AB equals? Because we can count from A to B, so this confirms that this actually does come up with the correct distance for us. Now, as your exact answer, you're just going to come in here and you're going to type in, again, your AB equals 8. All right, so for my exact answer, I want to say AB equals 8. Now, an approximate answer you can see says that we need to round to the nearest hundredth. Okay, well, this is a terminating decimal. It's 8.00000, right? So in this case, our approximate answer is actually an exact answer. We're just going to say AB equals 8. We will have questions where it will not be an exact answer, and you will have to round to the nearest hundredth. We'll see one of those in just a little bit. All right. Okay. Got a weird little square rooty guy there. All right, here we go. Now, let's find the midpoint for this line segment. So let me show you how to do that. By the way, according to your paper, where should the midpoint be? No, okay, yeah. But what's the address? Good job. You're right, in the middle. Kudos. But what's the actual address for this one? 2, -4. So that's what we should come up with, right? All right. Good job. No, let's give you props for that one. All right, here we go. You ready? Okay. So what is the name of our midpoint for this problem? C. Okay, so it's point C sits at, and then again, I'm going to do some big parentheses here because I'm creating one big ordered pair. And I told you I wanted you to start off with a couple of fraction bars in here, right? And then we're going to write in the math problem. So it's add the 2 x coordinates and add the 2 y coordinates, and everything is going to be divided by 2. It's always divided by 2, so we can write that in like that. Okay, so I'm going to go x1 and x2, so I'm going to go -2 plus 6. And then I'm going to go y1 plus y2. I'm going to go -4 plus, okay, I don't want 2 operators in a row, so I got to put that in parentheses, -4, like that. So this is what you're going to type in for the first step where it says midpoint for this problem. So let's do that together just so you have a good handle on how to do that. There we go. So when you're typing in your midpoint, you're going to start with your, where we go? So I'm going to start with my point, and then I'm going to get a set of parentheses, and then I want, inside my parentheses, I want a fraction. I'm going to arrow over till I'm outside the fraction. See it there? Put a comma, and then another set of fractions like that. And then you can just kind of work your way around these fractions. Like I know that the bottoms always have to be 2, so I can just kind of work my way through until I get 2 using my arrows. And then for the top of the first one, right, we said it was going to be -2 plus 6. So I'm going to write that in for the top of the first one. And when I go to the top of the second one, it's going to be -4 plus, and again, we don't want 2 operators in a row. So we got to put that in parentheses, -4, like that. Okay? That's what your type in for the midpoint formula for this problem should look like. Are you getting the idea of what you're going to be doing on these questions? I'm trying to build your habits of remembering the midpoint formula by typing these things in here. Okay, now, on the next level, we are asked to simplify our numerators. So on the next level of our problem, we're going to go like this. C is equal to, all right, so -2 plus 6. So what's -2 plus 6? Okay, that's +4, right? So +4 over 2. And then what's -4 plus -4? Yeah, it's -8. I borrowed $4 and I borrowed another $4, right? So now I'm in the hole $8. Divide that by 2. That's what you type into the next level of your problem. And then for your actual midpoint, you finish simplifying this up. So what is 4 divided by 2? 2. And what is -8 divided by 2? What's -8 divided by 2? -4, which is where we said the midpoint should be. All right, you finish typing those in for that question. All right, go ahead. I want to show you something real quick. So you should have figured out that the distance for this line segment is 10, right? Okay, now, this is not one that we can count straight down because it doesn't, you can, for one thing, the distance from corner to corner on a graph grid is not 1, okay? We'll talk about why that is at another time. But even here, it doesn't really hit the corners clearly, so it's not like we can count down the line like this. So that's where we have to use our distance formula when we can't count straight across horizontally or straight up and down vertically. But what we can do is verify it with our compass tool. So I want you to take your compass, and I want you to put it at point D, and then I want you to open your compass up so that you can draw a little arc right through point E here. So I want a little arc right through point E there. So from D down here to point E, so I can just put a little teeny mark so I know it's going right through that point, that intersection. And then watch, here's what I'm going to do. I'm going to come down here, and I'm just going to pick any random spot that's kind of like not really a part of my problem. And then I'm going to take that same compass point, I'm going to put it right here, and then I'm going to come out here, and I'm going to mark a little arc out here. And what that should show you right there is the other end of your line segment from where your pointer is. All right, and if you count, watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because things that are equal to the same thing are equal to each other. Oh, there's Euclid again. Look at that. Okay, right? Analytic and synthetic. You're doing both of them, and so now you can see how the distance formula comes into play. Okay, so if you want, as you're going along and doing these questions, if you're like, okay, I want to see how that measures out with my compass, I can check it. All you can do is take your compass sitting along that line and then go find a horizontal or vertical measurement, and you'll see that what you calculated is correct, because if you got the points in formative, then you know it's correct. Okay, we got one more that we got to do, and we got to talk about it in class. You should be working on question number 5 now. You're going to upload your picture for question number 5, and then we'll work on some distance and midpoint formula. So question number 5, this is the one that's got R at -7.1 and S at -3.7. So question number 5. Make sure you're doing the right graph. Question number 5. RS from -7.1 to -3.7. RS. Okay, go ahead and do that one. Question number 5. Okay, so we're going to write the distance workout. We're not going to type it into formative just yet. I'm going to let you go back and type it into formative. But I want to show you something with this question. So let's set up a distance formula. So we're going to be working on segment RS. And I need a nice long square root sign. Okay, everybody should be writing right now. That's what you're doing. You're taking notes. We're doing this problem together. If you're doing anything other than that, then you're not doing what you're supposed to be doing. Okay, so we're going to set up some parentheses that are being squared here and some subtraction problems so that we can do our RS. Okay, so R is -7, S is -3. So we'll just call R ordered pair number 1 and S ordered pair number 2. So I'm going to go -3, and that's going to be minus -7. So I'm going to put that in parentheses. You put it in parentheses if there's double operators. So if you have 2 math operation signs. Okay, and then I'm going to go 7 minus 1 for my y2 minus y1. Okay, now let's just move to the next level. We're not typing this in right now. Okay, so next level is we're going to say RS is equal to, again, I'm going to need a nice long square root sign, and I'm going to start simplifying my subtraction problem. So I'm going to need something squared plus something squared. All right, so -3 minus -7. -3 minus -7 plus 4, right? Because minus -7 is plus 7. So -3 plus 7 is positive 4. Okay? 7 minus 1? 6. All right. Okay, let's keep going. Distance of RS is equal to the square root of. So 4 squared is?
16.
And 6 squared is?
36.
All right. And so then we simplify the inside. Now this is where students get tripped up. Okay? Because you look at those numbers and you go, ooh, 16, 36. Those are perfect squares. But you can't do that right now. You don't get to take the square root. Now you have to add those together first, which is going to give you the square root of what? 52. Okay? Now, 52 is not a perfect square, is it? Right? In fact, if you think about it, the square root of 52 falls somewhere between the square root of 49 and the square root of 64, right? Like on a number line between 7 and 8. So it should be somewhere between 7 and 8, because the square root of 49 is 7, square root of 8 is 64, this is the square root of 52. So this right here is what we would call the exact answer. And that's what you're going to type in on the exact answer line. But this requires an approximation, and so that's where you're going to take your calculator and you're going to go square root of 52 in your calculator, and then you're going to say that RS is approximately, well, we'll just use an equal sign. Probably should say approximately, but I think I have them all set up, so we'll just use an equal sign for now. It's about equal to, and then you're going to round this to the nearest hundred. So if you do this, you should get 7.2111 something, right? What is it? 7.21110 something, blah, 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 right? And then we're rounding to the nearest hundredth. So rounding the nearest hundredth, that means that I want to have that be the end of my number there. So that means I got to look at the thousandths and round up.
I could get a 2 square root of 13.
Yeah, that's what I got.
Okay, so that'll give you the simplified square root. So if you hit the little SD button on there, it'll give you your decimal approximation.
How do you put SD? How do you put that in calculator?
Well, it depends on your calculator. You'd have to show me your calculator. So you have a little SD button on your calculator right there. This is kind of the lower right-hand corner. And if you press that, it'll give you the decimal approximation of your answer. So this is the approximate answer rounded to the hundredth is 7.21. That's what you type in for approximate answer. I'm going to come around and I'll take a look at your calculator to see some help.
Yeah, I don't see that.